of the things you should probably do right now is take a moment to think, how do you think the potential energy of the sphere right here will compare with its kinetic energy down here? Now, how you answer this will depend on if you did the assigned reading or not. If you didn't do the assigned reading, you may want to refer to your textbook. Okay? Because I promise you, this is not going to turn out the way that you think it is. Okay? Pretty good so far? All right, a couple of other things about this lab. The first thing is this. You have to calculate the change in the potential energy of the sphere. Okay? From when it started here to when it ended up down here, which should be negative because it loses potential energy, right? Okay? What? Well, let's just say this. If you set the final heights at the level of the track, what does that make the final potential energy?
0.
Sheridan? 0, which makes your calculations a lot easier, right? Everybody good? If you're going to do that, though, you need to know the height of the starting position from the track up to where they started. Good? Which means you may want to do something like this. Put a meter stick on here and measure from the bottom of the meter stick, because that's the same height as the track, right? Up to where the sphere starts. Everybody okay? Also note that where the sphere starts on here is left entirely up to you. It says somewhere in the middle in the procedure. If you start the sphere way down here, then it may roll so slowly that friction has a very large opportunity to act on it. Meaning its velocity slows down a lot. In addition to that, the height that you start at is so small that the uncertainty in your height value turns out to be a pretty big percentage of your actual height. So you get a large uncertainty. Okay? On the other hand, if you start the sphere way up here, so much for worrying about the uncertainty in your height, right? You minimize that. However, realize that you're ready, set, go, go. The time value is really short, right? Which means the opportunity for error in your time value is very large compared to the time value. So you need to choose somewhere in between those extremes so you get the best you can of each of those problems. Making sense? How are we doing? Everybody okay? All right, you're only going to run one trial.
Oh.
What?
Kill myself.
What? And all 3 people in your group are going to time that trial. And then you'll take all 3 times and average them. Okay? All right? What?
So doesn't that mean that the uncertainty of the times be based on like the average, not
Yes,
like the reaction time?
But realize that while it's not based on the reaction time, the shorter those time values are, the more likely you are to have a very large spread between them. Okay? The larger those time values are, the smaller that spread is likely to become.
Can you repeat that?
Sure. The shorter your time values, the faster the sphere is going, the larger the percentage of the times the range will represent. Okay? So when you take the range, the difference between your high value and your low value, okay, that value will tend to be very large compared to your average if your time values are small. But if your time values are big, that range will tend to be small by comparison with the range of your average time. Okay? So you're still stuck with that, even though you got around your reaction time issue. You still have that problem. Okay? Everybody doing all right? Any questions on this so far?
What was the reading?
What was the reading?
Yeah.
Yeah, I never saw that.
B1.4, blah, 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 I'll announce it later if you want to put it on the board. Okay? So here's what a couple other things here. Yeah, go ahead. A couple other things here. Okay? The back row of tables is going to use A setup. The next row of tables will use another setup. The next row, everybody good? Because there's only 6 of these, 6 of the tracks total available. Everybody all right? You can do this all in one trial for both the group on this side of the room and the group on this side of the room, right? Just have everybody ready to go in timing. All right? If you're over here, because, yeah, all my groups with just 2 are on this side of the room, we're unbalanced.
Oh my gosh.
Yeah, I know. If you have a group of 2 right now, you can make one of 2 choices. It's up to you. Okay? One is you can go, okay, I just drafted Stephanie to be in my group. And Lacey's going, wait, you stole my partner. And then Lacey can go to another group. You can rearrange to have groups of 3 if you wish. Or, if you have a group of 2, you can say, we're happy with our group. We don't want to mess this up. Okay? In which case, you get your 3rd time from the other group. Okay? Does that make sense? From somebody in the other group. Be smart, choose the time that's closest to the 2 you've already got. Okay? Colin, you got a question?
No.
We're good? Now, of course, while you're collecting data, what will I be doing?
Checking your homework.
Checking your homework. How'd we do on problems 1 through 3?
Easy.
Those were easy. Good. 4, 5, and 6 are on the board. We'll talk about them in a little bit. After I checked and you guys have gathered data, we'll talk about those problems. Okay? Everybody good? Okay. The students are at the back. You can use your phone or